Hello students. So here are the suggested solutions for exercise 1B which you can use for your corrections. Right, so the first question, find each of the following using prime factorization. So since they require us to use prime factorization, let's go ahead and do just that. So we're going to begin by writing. Let me get my pen up. Two, 9, 1, 6. Let's factorize this with 2. We will have 1, 4, 5, 8. Let's divide by 2 again. That gives us 729. Let's continue the process. This time round, not divisible by 2 anymore. Let's go 3. We'll have 243. Let's continue the process. 81. Well, it's pretty long, right? Because they are make sure you have sufficient space. But we keep going, right? We'll not stop until we hit 1. That is the determination. Oops. Let me go back. It should be 9. And almost there. And we finally hit 1. So let's look at the prime factors on the left column and put them all together. So this tells us that 2916 is equals to 2 to the power of 2 times 3 to the power of 6. So with this, we can actually rewrite it in the form 2 times 3 to the power of 3 squared. Why is this so? I've actually explained to you in class. So now that we have it in the form of something to the power of 2, right, written in the bracket, we can now safely find the square root of 2916, which contains just the bracket section, 2 times 3 to the power of 3. And we simplify this should give us 54. Let's move on to the next question. Next question, we are already given the prime factorization form, right? This time round, it is written for us. 24,336 is equals to 2 to the power of 4 times 3 to the power of 2 times 13 squared. And we are told to find the square root. So when it says without the use of a calculator, so we're not going to use calculator. You can use calculator for checking, but not in the showing of the process at which we obtain the answers, right? So from here, what we can do is we can rewrite this in the form 2 to the power of 2 times 3 times 13 to the power of 2, right? So from here, the square root of, let me write it down, 24336 is equals to 2 to the power of 2 times 3 times 13. So this works out to be 156. Right, next example. This time round, we are going to find the cube root of 5832. Right, so let's go ahead and do the prime factorization. So 5832, right? When we divide by 2, what do we get? We get 2916. Continue the process. We get 1458. One more time. We get 729. Right, then we go to 3. This time round we have 2, 4, 3. Continue. 81, 27, 9, 3, 1. Right? So that tells us that 5832 is equals to 2 to the power of 3 times 3 to the power of 6. Well, we can rewrite this as 2 times 3 squared to the power of 3. So from here, the cube root of 5832 is equals to 2 times 3 squared, and this works out to be 18. All right, let's move on to the next one. Well, we have one more. Okay, this time round, it has already been nicely factorized for us. So what happened is this, we can actually write it as 2 to the power 3 times 3 times 5 and the whole thing to the power 3. So this tells us that the cube root of 1728000 is equals to 2 to the power 3 times 3 times 5, right? So that will give us 120, right? Let's go on. Next one. Now this time round, this is a different type of question. We are told to actually use our calculator to evaluate this expression over here and to actually round it off to 4 decimal places, right? So we work this one out using calculator. We get 1.002436942, etc., right? So we round it off. It should be 1.0024. And we have to declare it is 4 decimal places. Okay, right, let's move on to the next one. Now Raju, well, we have let's see, Raju has a 2020 or 2021 centimeter square tile. He makes the largest square possible using some of the square tile, right? What did he get, right? How many was left over? So what can we do here? Well, first of all, let's try to square root 2020. That will give us a good idea, right? We're going to get the floor of it. So if we square root 2020, we'll find out that it is actually 44.9444, etc. Now we can't use 45, obviously. We can't actually have more square tiles than he actually had. So we'll take the floor. What I mean by taking a floor is I will round down, right? So when I round it down, it's actually 44. That means, right, the largest square, right, the largest square is 44 tiles by 44 tiles. Therefore, the number of tiles left over is going to be equals to 2020 minus 44 squared. And that works out to 84 tiles. There we go, right? Okay, moving on to the next one. Question 12. Use prime factor to explain why 6 times 54 is a perfect square. Well, you have something similar in your handout, right? So what happened? 6 times 54 works out to be 2 times 3 times 54 will be 2. 54 divided by 2 gives us 27. Then 27 is actually 3 to the power 3, right? So we continue to simplify this. This will be 2 squared times 3 to the power 4, resulting in 2 times 3 squared. So since 6 times 54 can be expressed in the form n squared, it is a perfect square. There we go, right? Part 2. K is a non-zero whole number. So given that 6 times 54 times k is a perfect cube, write down the smallest value of k. So here we go. 6 times 54 times k is actually the same as 2 to the power 2 times 3 to the power 4 times k, right? So what happened is, if we want to make this a perfect cube, this have to be actually be equivalent to 2 to the power 3 by 3 to the power 6. So just by comparing, we can figure out that therefore k is equals to 2. I need a copy of 2 so that 2 square can become 2 cube, and 2 copies of 3 times 3 to the 3 square, resulting in the 18, Okay. Now part 3. Part 3, we have 6 times 54 times P over Q. This is a perfect cube, right? So similarly, let's write it down in its prime factorized form. 2 to the power 2 times 3 to the power 4 times P over Q. Okay. So using the same idea, right? What happened is our result from here is going to be 2 to the power of our perfect cube, right? So we want it to be 2 to the power 3 and 3 to the power of 3. That means to obtain this, we need to actually multiply by P, right? Multiply by P and divide by Q. So just a quick comparison, we will have the answer already. So we need to multiply by 2, so P is equals to 2. And we need to divide by Q, so that is divide by 3, so Q is equals to 3. Right? So that's how you can actually show your presentation. Now moving on to the next one. The final question of this set of assignment. Express 4704 as a product or its prime factor. Well, that one we can do quite quickly, right? We have a lot of experience with that. So 4704, let's work it out. Divide that by 2, that'll be 2. 7 divided by 2 gives us 3. 5, 2. Let's continue the process. 1, 1. 7, 6. Continue. 11 divided by 2 gives us 5. 16 gives us 8. 5, 8, 8. And we can continue to go, right? Some more. So this gives us 2. 9, 4. Divided by 2 again. Right? We get 1. 8 divided by 2 is 4. 7. Did I get that right? Yep. And then over here we can divide by 3, right? So let's go divide by 3. Divide by 3 gives us 40. 27 divided by 3 is 9, 49. That means 2 copies of 7. We'll do it. And we're done. Okay, so now let's write it properly. Therefore, 4704 can be expressed as 2 to the power of 5, right? Times 3 times 7 squared. Done, right? So let's go on to the second part of the question. The second part of the question, they tell us that 4704 over m equals to n squared, where m and n are whole numbers, right? And n is as large as possible. So how do we do this? Well, what happened is 4704 over m. Let me label it properly. Let's go back a little, right? Let's label part 2 properly. So 4704 over m equals to n squared, right? So 4704 is 2 to the power 5 times 3 times 7 squared, right? Over m equals to n squared. So if you look at it carefully, what happened is n squared over here simply means perfect square, right? This means perfect square. So we already understand that perfect square means the power has to be even number. So if you look at that, then we will know what do we need to get rid of so that we get a perfect square, and whatever we need to get rid of is actually our m, right? So to do that, just a quick check, we have 2 to the power of 5 here, so we need to make it 2 to the power of 4. So m has to have a copy of 2, right? Because 2 to the power of 5, if I divide by 2, it will be 2 to the power of 4 perfect square. Well, we need to get rid of 3 as well, so there's a 3 in m as well. And then 7 is fine, so we leave 7 alone. That means m is equal to 6, right? So if m is equal to 6, then n squared is actually equals to n squared will be equals to whatever is left behind, so it will be 2 to the power of 4 times 7 squared, right? So that means this is actually equals to, well, let me pull out the paper, need to zoom in a little bit. So this is 2 to the power of 2 times 7 squared, right? So that's what n squared is. So from here, n is actually 2 to the power of 2 times 7 That gives us 28. Alright, so finally the last part of the question, we have this. Find the smallest whole number h such that 4704 is a perfect cube. So first thing, let's label. I'm going to do part 3 over here. So 4704 over h is equivalent to 2 to the power of 5 times 3 times 7 squared over h. Well, since we want this to be a perfect cube, that means we want 2 to the power of 3. So h must actually contain 2 copies of 2, right? So just by comparing, h must have 2 to the power of 2, right? Because this portion over here has to be 2 to the power of 3. Do I want to get rid of this 3? Oops. Yes, I want to get rid of 3. Therefore, my h must also have a copy of 3. 7 squared also can't make a perfect cube, so I need to actually divide it away and put it in h. Right? So you work this one out. This is 558. Alright, so that's the assignment that I tasked you to try. I hope you have been successful. If not, do finish up your corrections and review your corrections so that you learn something. Okay? Have a nice day.